Hello everyone, myself Deepak Shah from New Catholic Mission School Jhabwa, and today's video is for class 12th subject mathematics chapter 5 continuity and differentiability. So continuity is the chapter which we studied in class 11th as chapter 13 limits and derivatives. In 11th we have chapter 13 which is named as limits and derivatives. So limits and derivative is the continuation of continuity is the continuation of limits and derivatives. Limits is related with this continuity and derivatives are related with differentiability. So chapter 13 class 11th is very important for this new chapter, chapter 5 continuity and differentiability. Limits we solve in class 11th, so the continuation of this limits is continuity, and derivatives also we solve as differentiation, so this is called differentiability. Now we move towards our chapter, that is continuity and differentiability. So first is, what is continuity? What is continuity? Suppose f is a real valued function on a subset of a real number, and C is any point in its domain. So C is so f is continuous at x equals to c if limit x tends to c fx equals to fc. Okay, or in 11th class we solve LHL, left hand limit equals to RHL, right hand limit, and equals to value of function, or we write it as limit x tends to c minus, left hand limit is or at c minus or value negative, and limit x tends to c plus at RHL and functions value x equals to c. If these three are equal, then we say limit exists, and here we say if these three are equal, then the function is continuous, otherwise it is discontinuous. If c limit x tends to c minus equals to limit x tends to c plus equals to fc, or LHL equals to RHL equals to fc, then we say that function is continuous, तब function continuous कहलाएगा, otherwise it is not continuous. If f is not continuous, then it is said to be discontinuous, and C is called point of discontinuity. Okay, if f is not continuous, it means these three are not equal, then f is called discontinuous and C is called the point of discontinuity. Okay, so this is all about continuity, and we move. One more thing, if there are two functions f and g are two real functions, let f and g are two real functions continuous at x equals to c, then first f plus g is also continuous at x equals to A or C. Second is f minus g. It means subtraction of both function is also continuous at x equals to C. Third is f dot g. It means multiplication of two function is also continuous. If f and g are continuous, then multiplication of these two function is also continuous, and f upon g is also continuous at x equals to C. It means if we have two functions f and g which are both continuous at x equals to C, then their sum, their subtraction, their multiplication and their division is also continuous at x equals to C. Okay. Now exercise 5.1, we solve some questions of this exercise. First question number 2. Examine the continuity of a function. Examine the continuity of the function. Function is given as fx equals to 2x square minus 1 at x equals to C. So, if the function is continuous, then we have to prove LHL equals to RHL equals to FC. So, first we put x equals to C. It means x equals to 3 in this function. So, we get f3 equals to 2 into 3 square minus 1. So, 3 square is 9, 9 2s are 18, minus 1 is 17. So, this is the value of FC, fx equals to C. Now, LHL, left hand limit, limit x tends to 3 minus, okay, the value is x equals to 3 and we take LHL as x equals to x tends to 3 minus, and the function is 2x square minus 1. So, how much less than 3 its value? So, its value is less than h, 3 minus h. Now, function change into h tends to 0 and we put x as 3 minus h square minus 1, and the value of h tends to 0. So, we write it as 3 minus 0 square minus 1. So, it becomes 3 square minus 1, it is also 17. So, value of LHL is also 17. Now, we take RHL, limit x tends to 3 plus. In RHL, we take positive sign. So, and the function is same, 2x square minus 1. So, how much greater than 3? It's 3 plus h, and function change into h tends to 0 to 3 plus h square minus 1. If we put h equals to 0 here, then we get 2 3 square minus 1, that is also 17. So, here value of f3 is 17, value of LHL is also 17 and value of RHL is also 17. So, LHL equals to RHL equals to f3. These 3 are equal, then the function is called continuous function. So, this function is continuous at x equals to 3. Okay. Now, next question, question number 6. Question number 6. In this question, there are intervals given. There are two intervals given. Fx equals to 2x plus 3 at x less than equals to 2 and 2x minus 3 at x is greater than 2. Okay. There are two values given. It means at x less than 2 or equal to 2, the value is 2x plus 3, and at x is greater than 2, its value is 2x minus 3. So, first we take x equals to 2. At x equals to 2, the function's value is 2x plus 3. So, f2 equals to 2, or we first write as fx and 2x plus 3. So, f2 equals to 2 into 2 plus 3, value is 7. LHL, limit x tends to 2 minus, it means less than 2, x, value of x less than 2 is at this function. So we write 2x plus 3. How much less? It's h less, 2 minus h. So we write limit h tends to 0, 2 into 2 minus h plus 3. So limit h tends to 0, it's 4 minus 2h plus 3, value of h is 0, so the value of LHL is 7. Now RHL, limit x tends to 2 plus, it means x, value of x is greater than 2, it means we take this function at greater than 2, 2x minus 3. How much greater? It's 2 plus h. Now limit h tends to 0 to 2 plus h minus 3, value of h is 0, so 2 2s are 4 minus 3, it means its value is 1. So value of f2 is equals to value of LHL is not equal to RHL. These three are not equal, it means function fx is discontinuous. Function is not continuous, discontinuous. Okay. Now next question. Question number 13. This is also in the form of interval x plus 5 and x minus 5. X less than equals to 1 and x is greater than 1. So x equals to 1, f1 1 plus 5, its value is 6. LHL, limit x tends to 1 minus, it means the function is x plus 5. How much less? H less. So the value is limit x equals to 1 minus h. So at the place of x we write 1 minus h plus 5, value of h is 0, so its value is 6. LHL is also 6. RHL, limit x tends to 1 plus, for 1 plus it means greater than x, 1 is x minus 5. So 1 plus h minus 5, it means minus 4. So value of f1 is equals to LHL, not equals to RHL. Function is discontinuous, not continuous. Okay. Next question. Question number 23. Other questions are similar. So we take question number 23. Fx, trigonometric function, fx equals to sin x upon x. If x is less than 0 and x plus 1 if x is greater than equal to 0. So this is the function given, and find all the points of discontinuity of f. So we have to prove that it is continuous or discontinuous. If it is discontinuous, then find the points of discontinuity. So we first take f0, it means x equals to 0. At f equals to 0, we have this function 0 plus 1, it means its value is 1. Then we take LHL, limit x tends to 1, 0 minus, value is 0. So less than 0, the function is sin x upon x. So we take sin x upon x. How much less? It's 0 minus h. Okay. So limit change into h tends to 0, it's sin 0 minus h upon 0 minus h. We know that sin minus h upon minus h, we know that sin minus theta equals to minus sin theta. So we write it as minus sin h upon minus h, h cancel to h, minus cancel to minus, then we get this. And we know that limit x tends to 0, sin x upon x equals to 1. In previous classes we know this formula or this value, so it becomes 1. Now RHL, limit x tends to 0 plus, at 0 plus it means greater than 0, the value is x plus 1. How much greater than? 0 plus h. So limit h tends to 0, it becomes 0 plus h plus 1. Value of h is 0, so the value is 1. So at x equals to 0, value is 1. At LHL, it means less than 0, its value is 1, and at RHL, at 0 plus, its value is 1. So all these three values are same, therefore the function is continuous. There is no point of discontinuity in this question. Okay. Now next question, question number 26. In question number 26, the function is given as continuous, but we have to find the value of k, constant. The value is given as fx equals to k cos x upon pi minus 2x if x is not equals to pi by 2, and 3 if x equals to pi by 2. And we the function is given as continuous function, and we have to find the value of this constant k. So first we take x equals to pi by 2. So function fx equals to 3, value of x is pi by 2, so the value is 3. Then we take LHL, limit x tends to pi by 2 minus less than the value of x. So less than value of x means pi by 2 minus, we take this function k cos x upon pi minus 2x. How much less than pi by 2? It's pi by 2 minus h. Okay. So limit function change into h, h tends to 0, k as it is, and cos value of x is pi by 2 minus h upon pi minus 2, and value of x is pi by 2 minus h. Okay. So limit h tends to 0, k as it is. We know that cos 90 minus theta, cos 90 minus theta is sin theta, so it becomes sin h, and pi minus 2 cancel by 2, so pi, and minus minus plus 2h, this pi cancel by pi. So limit h tends to 0, k by 2, we take k and 2, and this sin h upon h. We know that this and this becomes 1, so the value is k by 2. LHL is equals to k by 2. Now we take RHL. RHL, and RHL means limit x tends to pi by 2 plus, at pi by 2 plus, same function k cos x upon pi minus 2x. How much greater than pi by 2? It's pi by 2 plus h. So function change into h tends to 0, k cos pi by 2 plus h upon pi minus 2 pi by 2 plus h. Okay. Now we all know that cos 90 plus theta in second quadrant, value of cos 90 plus theta is minus sin theta, so it becomes minus sin h, and here pi minus h, this 2 cancel and 2h. So we take k by 2 and sin h upon h minus, so this 2 cancel and limit h tends to 0. We know that this and this have value 1, so only k by 2 remains, and the function is given as continuous function. given function is continuous. Therefore, LHL equals to RHL equals to f pi by 2. Value of LHL is k by 2. Value of RHL is also k by 2 and value of k pi by 2 is 3. Okay. So, we take k by 2 equals to 3. So, k equals to 6. Value of k is equals to 6. Similarly, we solve question number 29. One more question to find the value of k. Question number 29. Value is kx plus 1 at x less than equals to 5 and 3x minus 5 at x is greater than 5. So, we take first x equals to 5. So, at x equals to 5, the function is kx plus 1 because x equals to 5, kx plus 1. So, we write x equals to 5, so k into 5 plus 1, its value is 5, k plus 1. Now, LHL less than 5, x tends to 5 minus. So, at less than 5, we have function kx plus 1. How much less? 5 minus h. Limit change into h tends to 0, k. At the place of x, we write 5 minus h plus 1. Value of h is 0, so it becomes 5k plus 1. Similarly, RHL. Limit x tends to 5 plus. Limit x tends to 5 plus. So, greater than 5, we have 3x minus 5 and x equals to 5 plus h. So, limit h tends to 0, 3 into 5 plus h minus 5. 5 3s are 15 plus 0 minus 5. So, value is 10. Here function is continuous. So, LHL equals to RHL equals to f 5. LHL, value of LHL is 5k plus 1, value of RHL is 10 and value of f5 is 5k plus 1. So, 5k plus 1 equals to 10, 5k equals to 9 or k equals to 9 upon 5. Value of k is 9 upon 5. Okay. So, similarly you can solve some more questions of this exercise, and this is all about continuity of a function. Okay. Thank you.